Welcome back, everyone. So it's been a long time and I've been really busy with corporate work and some personal projects, and I really just couldn't find the time to make these videos. Now, since the pandemic is going on, I believe everyone is having some hard time working with the time and the work itself. So it's been quite a tough months, pretty busy schedule and so on, and I have a new product coming up soon, so stay tuned for that. Anyways, I'm back, although the frequency of the videos won't be just like before, but yes, it will be still there, but the frequency will be a bit slow. And as soon as I find some free time, I can get back onto the track and start making more of these. I have tons of new content. It will be a bit slow, but yes, it will be still there. So anyways, I hope everyone is doing fine, and in today's video we are going to talk about the expressions. So what are expressions? Expressions are basically a coding language in a way, similarly like Python and Mel. By expression, you can pretty much write a certain amount of code that you give to your software, and that software reads it and perform it into the action. So you can do this type of expression in After Effects as well. So similarly, like Espresso, Coffee, Python, Java, so on, expression is another coding language. So we are going to kind of dive into the whole basic structure of it. We are not going to get too deep inside of it because the expression is too big to cover it in a small video. But I'll try to explain it as smoothly as possible, just so you have the basic idea of what expressions really are and what you can do with it. So if you really have interest in expressions, you can read the docs and everything, the whole Mel coding and everything, and you can learn it by yourself. So this will just give you the basic idea of how you can get started with pretty much anything regarding expression. Alright, so the first thing I'm going to do is take a simple cube, and this is my default cube, and let's say if I want to animate this, what I will do is basically hit S on my keyboard and I'll go to about 40 frames, and I will pretty much move this here to about here, and I will hit S again. And if I play this, so this is my manual keyframe and the cube now stops. So this is basically the overall traditional way of keyframing and animating. So instead of keyframing, what we are going to do is basically, this is our cube, I'm going to go to edit. So if I go into my cube here, I'm going to select my cube, and if you go to the edit, you won't see the expression is kind of a gray scale. That means it cannot be selected, and the reason is because you haven't actually selected any you can say parameters. For example, if I select my translate X and if I go to edit, now you can see the expression. So you can find your expression right here. So I'm going to say expression, and by default you get this kind of window, which is the expression editor, and this is where you'll be doing all the stuff. And so basically the next thing is you have all these parameters, like for example you have translate X, Y, Z if you want to animate that, or the visibility, or rotate, or scale. So in this case I want to pretty much animate translate X without actually keyframing. So the first thing is to copy the attribute of the actual object. In this case we have PQ1, which is this, and what is the parameter that we are going to be animating? That is translate X. So I'm going to copy this whole thing instead of typing it down, and I'm going to simply paste this, Ctrl C and Ctrl V. So since the expression editor is pretty small, I'm going to hit Ctrl and scroll wheel to kind of make it bigger, just so everyone can see, and right about here. Okay, so this is what we have. Alright, so the next thing is what we can do with this. So this is our basic function, like what we are going to be animating. So I'm going to hit equals, which now we are defining what we are going to do with this. So if I hit frame, alright, and if I hit create, obviously without creating nothing will happen. So if I play this, nothing is happening. So I'm going to hit create. Alright, so you'll notice that the PQ1 has moved one frame forward. I can do the same. I can, let's say I want to move this a little bit higher, so I'm going to animate this into the Y direction as well. So I'm going to hit enter. I'm going to paste the same value and I'm going to hit Y. Remember, expressions are case sensitive, so make sure you have the capital or small y depending on what you are typing. And I'm going to hit frame as well, and I'm going to hit edit, and if I hit play, nothing is actually happening, and you won't see the y direction. It's still going in the x direction, it's not taking the y direction. And the reason is because to end a certain amount, since we have 2 line of codes here, we have to tell the expression editor that I've ended this line. This is a separate function on its own, and then I have a different function here. So to end this, all you have to do is add a semicolon. And I'm going to add a semicolon to this as well, and I'm going to hit edit. Right, so now if I see this, you'll notice, just minimize this, go to first frame, that with every frame that we go higher and higher, it's going 1 frame, 1 unit forward in the x direction and 1 unit higher in the y direction as well. So there you go. So if your functions are not working exactly how it's supposed to be, make sure that you add a semicolon. If you are familiar with the coding language, you're pretty familiar with semicolon. This is how you end a statement or whatever functions you're writing. So always keep in mind that you have to add a semicolon to end a certain type of, not certain type, any type of codes or function that you're writing. Anyways, moving on, I'm gonna show some symbols that you should keep in mind when you're working with expression. Like the first thing is, since we are animating translate x, we don't necessarily have to write the whole thing down. You can also use a simple tx for translate, which is basically tx for translate, sx for scale, and so on and so on, depending on what you're animating. So you can use this, you can type frame, you can edit this, and so on. So it will automatically take it as translate x. So now it's just a bit more easier for you to, instead of typing the whole thing, you can just type in tx and not tx, like ty, and hit edit, and it will automatically transfer it to translate y. So pretty helpful tip. Anyways, moving on. So the next thing is comments. What are comments? So basically, if I put 2 dashes, that's a comment. For example, I'm gonna copy paste this is equal to, I'm gonna hit time, and we'll get into time, what is time and how you can use it. And I'm gonna hit 2, and I'm gonna hit edit. Alright, so if I play this, nothing is actually happening. Alright, so what I'm gonna do is type in here the same thing. I'm gonna use the y, I'm gonna hit time multiplies, let's take 2, and hit edit. Right, so if I move this, you can see this is working and this is not. And the reason is because we have to pretty much do the same thing with this one. Since this is a comment, we always have to end a statement. Like for example, if I use remove this and hit edit again, you'll notice that it's also moving in the x direction. I'm gonna remove this for now, just so you can see the x direction. It's moving in the x direction, and I'm going to take this, I'm going to use y, and let's use time multiplied by 4, and let's semicolon. Always make sure you put an end to it, and it will start animating. But let's say if I add this as a comment, it won't be animating. So the comments are basically comments for you, or the overall language for you to understand what you are doing or what needs to be done in the script. So that's how you keep track of everything and everything. So I'm going to remove this, hit edit, both of them will kind of be animating again, and so on. And obviously there are some if and else statement and so on. And apart from that, there are some quotations that, like this one and this one, like I hope everyone knows quotation. And then there are braces, and which we are going to be using everything. But yeah, this is pretty much the symbols you should know if you are going to work with different types of scripting. Anyways, moving on. So I'm going to take the rotate X again. So how we can use this in a negative direction. Let's say we have been using this everything in the positive direction. If I hit frame and so on, and let's move it, you'll see this animation and so on. And for this certain type of the next animation, I'm gonna simply delete this and delete this as well, and let's remove this as well. All right. So in the translate, actually I forgot to edit this. All right. So in the translate, you'll notice one more thing, and that is the value here, so when I edited it, it was on the expression values. So that's why you have this 42 unit here. So I'm going to hit 0 here. And one more thing that you'll notice is the color of this translate text, that the expression that we are working on has been turned purple. That means it is driven by the expression. So this is a pretty handy thing when you're working with expression. This helps you keeping track of everything. Alright, so I'm going to go with this. So I have a translate text. I'm going to select this, and we also touch the Y value. So I'm going to go to the expression again, go to control, scroll. So we have been using all the things in the positive direction, but let's say you want to use something in a negative direction. All you have to do is use a minus. That's it. So you'll notice that the cube goes in the negative direction, negative 12 units. So in this case, if I play this here, it will still animate, but it will animate from the origin, and that is the minus 12 that we have given it as an origin point, the starting point in a way. Alright, so what else can we do with this? Let's see. So I'm gonna simply take, I by mistakenly deleted the cube. I'm gonna say, let's take, right, from the origin, let's hit multiply. So you can pretty much use the mathematical functions with this as well. Like for example, I can simply hit divide this by 2 and hit edit, and you will see the half unit of the cube from the origin, which is the 0, and now you have divided by 2 and you get this location. So you can use mathematical functions with this, which will kind of help if you have like a mathematical equation driven kind of project. This can help you with that. And you can do that same with the overall multiplication. You can multiply it with 2, you can hit edit, and now it will animate because we are animating with time. Alright, so we are multiplying every frame with 2. So now you get this kind of animation. Obviously, this totally depends on your FPS as well. If you have 30 FPS, 24 FPS, so make sure you set your FPS before the project. Alright, so you can also use this with a negative, like negative frame edit. So you have a negative 2 unit and then multiply it by 2, and then you have the still negative animation going on. So you can use a positive direction, negative direction, totally depends on you. And I'm going to hit edit and let me hit 0 again. So there you go. So let's move on to the next thing, the overall braces or the brackets. Alright, so let's take something else. I'm going to take a simple sphere here, and let's go to the expression, and I'm going to take maybe a scale. Let's copy this, and I'm going to hit control and scroll so you all can see. Now from here, what I'm going to do is hit equals, and I'm going to put something like frame again minus 2, and instead of just ending it, what we can do is we can put it in a bracket, right? And we can hit create, and now you can see we have something like this. Alright, a pretty nice, neat little animation. Obviously need some more topology. So what is basically what we are doing with the brackets, why we use brackets. So what we can do with brackets is basically I can also use brackets to pretty much animate this or do some mathematical addition, subtraction or multiplication, totally depends on you, with the other numbers as well. So now not only I'm animating frame but also with multiplication with time. So here what I can do is I can maybe change this to something like 4 and maybe 8, just to make it a little bit faster. And now there you go. So by default now you have minus frame 2. I'm gonna make this smaller, something like this, and this will just keep on going, and there is no like certain end. As long as you have a bigger timeline, it will just keep on going and going and going. And that is the overall power of the expression, that there is no like limit. You don't actually have to manually do anything. It is all driven by a simple coding language. Now, apart from this, you can also use this to some other stuff as well. Now I'm going to hit delete, and let's take a simple torus here. And I'm going to I'm going to reduce the section radius. Let's bring this up. And let's select this. I'm gonna freeze the overall transform here. Expression. Let's take the rotate Z. Control C, Control V. Scale this up, and I'm gonna hit brackets, and then you can use this. Let's use time, multiply it by 2, multiplied by 4, and semicolon, and hit create. And now if we look at this, you have a nice little slow animation of going the overall rotation of Z direction of the torus. Now we can obviously go back and make this a little bit faster. So I'm gonna hit 8 here, edit, and let's play this. Let's make it a little bit more faster, and there we go. So now you can see we have this kind of animation going on, and it's continuously looping. I mean, there is no stopping. It's continuously going on and on. Alright, so moving on. Now I'm gonna select the overall rotation here, expression. Alright, so what else can we do with the overall magnitude here? So now we are gonna get into the overall if-else statement here, and I'm gonna make this 0 again. Right. So let's say if we want to, let's start with something like maybe a translate. Let's say I'm gonna hit F. Alright, and there's one more thing that you need to understand is tab, and tab is basically adding some space when you're entering if and else statement, just so it makes a bit more clear sense of what your comments are and what your statement is, and so on. So if, let's say, brackets, my time is greater than 2, sorry, 2 is greater than my time, then I'm going to hit enter, and I'm going to hit tab, and from here I'm going to say copy this, paste this, translate x is equal to, and you can always use tx for the short version as well, to multiply by something like maybe tan, and what is tan, we'll get into what is tan, sine, and so on, time, and I'm going to end this here, and otherwise else I'm going to hit tab, and I'm going to use y, translate y is equal to ran, which stands for random, and let's just put some values like maybe 90 and 180 degrees, and I'm gonna hit a semicolon and create. Alright, so let's see what's happening here. Alright, so what the statement basically defines here is basically if the 2 value is bigger than the time itself, the p torus 2 multiplied by tan equals time. Otherwise, the translate y should be randomized in the overall translation. If I put something else, like for example, let's take something like rotate, and I'm going to hit edit. So I'm just going to hit frame here, and I'm going to hit edit, and let me just use 0 for this direction, and I'm going to hit greater than 2, and let's hit edit. Alright, so if I play this now, you can see the overall rotation happening here. So what this is telling is the frame, if the 2 is greater than the frame of the origin, which is the default right now, the 1, then the p torus translate x will, this is pretty hard to explain because I think there's a lot of things going on here with the overall statement. As I said, this is a pretty big topic to explain in a small video, but I hope you'll understand with time. With more videos, you'll try to understand. So 2 will multiply with tan, and tan are basically mathematical functions. You'll find more functions in the math functions here, cos, sine, theta, and so on. And otherwise, so it is basically like either if this is going to happen like this, then this kind of statement. So what we can do here is I'm gonna use something like maybe a sine. Alright, we'll multiply with time, and let's use time, and I think the overall rotation is a bit too much, so I'm going to reduce this to something like maybe a 40 and 60, and I'm going to hit edit again. So if I go back, you can see the overall animation. So the overall with if statement makes the torus move 2 units, and if it moves 2 units forward, if it's bigger than time, then the p torus y will start rotating. I'm gonna hit Z here and I'm gonna hit edit, and now you'll see the overall rotation. I'm gonna make this 90 again, and now let's make this 180. I'm gonna hit edit, and there you go. So I think the overall sign is not exactly working so great in our favor. And now you have this crazy looking animation without actual keyframing or anything. So this is all depending on the mathematical function, and this is just a taste of what powerful expressions are, how powerful the expressions are, and what you can do with it. It's a bit complicated to understand. It's a bit complicated topic to kind of teach in a small video, but I'm going to make a lot of videos regarding the whole expression, trying to do different kind of abstract stuff just so you can understand. It's not going to be a pretty interesting topic just so if I show you in a simple cube or torus, but just try to understand the basics here. Alright, let's get rid of this and let's do something else. Let's do something a bit more fun. Let's take a simple cube, scale this up, and so by default we get a simple color which is a lambda, right? I can right click here and I can say create new expression, and from here we have color. I'm gonna choose the color R here, copy this, paste. And what I'm gonna do here is I'm gonna use the same function is equal to time. So color R will be animating with time multiplied by 2. You can add 4 as well. Totally depends how fast or slow the movement you want it to be. If I play this now, you'll see the colors are actually animating. And I think I'm going to put 2 here just so we can see a bit more change. And I'm going to hit a semicolon here just so I can end the statement. And now you can see the colors are animating. So I'm going to do the same with this. I'm going to copy this, paste. Let's make it. And last one is RGB, and let's make it something like this. Right. So we have something like this. At the end of the animation, everything turns white. But instead of this, what we can do is I'm gonna add a rand here, which basically stands for random. So let's put rand here, and I'm gonna just put some random values here. Alright, so as you can see, the overall animation is not exactly working here because obviously I need something for this to animate with. So I can do is multiply this with 2, right? And I'm going to do this with the single one just so it's a bit more clear. And from here you can see we do get the red color, but not exactly in animating way. I'm going to hit edit. So how do we fix this? How we can make this a bit more animated and a bit more good looking? So what we can do is use another function which is basically taking the same mathematical function. So I'm going to take noise, and I think everyone is pretty much familiar with what noises are and how you can use the noise. And I'm going to use time multiplied by 2 and semicolon and edit. So if I go back and play this, now you can see the overall noise is working and how this is kind of pretty much animating, right? So I can do the same. I can copy this function, paste this here, and let's type in G, and I'm going to hit B. So instead I'm going to just change some time values here. I'm going to hit 6 and edit this, and now this will keep animating, and you can pretty much know more about the colors and everything by going to the color palette if you want exact precise numbers of the color and everything. Now you can do the same thing with not just the color but the overall values as well. So if I have something like, let's say I want to animate, I'm gonna freeze transform and translate an expression. What I can do is I can copy this here, and I'm gonna scale this up, and I'm gonna hit equals, and I can type in noise just so I can use noise as an animation, and I'm going to use frame multiplied by 2, or you can use time as well. And let's end this, hit create, and now if you look at this, you can see it's moving 2 units, or you can say multiplied by 2 every frame, by the noise pattern. So noise are usually generated in a black and white. I'm pretty sure everybody knows this, but just in case if no one knows, I'm gonna hit noise, and this is basically the noise R, a simple black and white pattern which can be used to animate random stuff depending on the random seeds and so on. So now you have this kind of animation going on. You can use other type of stuff as well. I can use the translate X. I'm gonna copy this again, paste it here, and instead of translate X, let's use Y, and I'm gonna hit equals sign, which is a mathematical function, and with time multiplied by 4, and let's add a semicolon here, and I'm gonna hit edit, and now you have something like this. Pretty interesting. If you don't know this mathematical function, I highly suggest going into the insert function, math function, and you can see you have tons of function. You can pretty much animate and play around with. You have Gaussian noise, denoise, random, and so on, and seeds and so on. So have fun with this, play around with this. As I said, this is a pretty big topic to teach in a small video. It is not something that you can learn it right away. You need time with it and some trial and errors kind of thing, but I will try to keep it short with the other videos as well. I'm gonna animate some cool stuff with it just so you can understand how you can use and implement this technique with abstract stuff or other kind of areas as well. Anyways, this was it. So I'll see you on the next video. It was fun. It was a pretty busy months and so on, but since I'm back, let's have some fun creating some amazing stuff, and I'll see you in the next video.